Hi students, the next topic is particle nature of light, Einstein explanation. Particle nature of light in Einstein's explanation. Actually, you know, according to Max Planck proposed quantum concept in 1900, but remodified in 1905. Einstein extended this Planck quantum concept. He explained the photoelectric effect. According to Einstein concept, the energy in light is not spread out over wavefront. That means it is concentrated in small pocket or energy quanta. That is, light is stream of quanta. Light is stream of quanta. See, according to Einstein, the energy in light is not spread out over wavefront, but it is concentrated in small packet like quanta or energy quanta. In peculiar point, light is stream of quanta. That is, any light source coming from light like a stream of quanta, that is, see, the light is coming like that. It's a stream of quanta. This is a stream of quanta. Light is like a stream of quanta. See, this is a nothing but particle. So light is an particle. Photon is nothing but light in a particle nature. So energy of each quanta is E is equal to h nu. That is, one single particle, the energy is equal to h nu. Even each quanta of light having linear momentum, the symbol is P. So P is equal to the momentum formula, that is h into nu by c. We will discuss about the next class how came this formula. So see, this is like a particle. This particle is nothing but photon is light in particle nature. See, it is a correct point. Photon is nothing but light in particle nature. Particle nature la photons எப்படி சொல்லுவானா like a light னு சொல்லுவோம். So generally photon is nothing but light in particle nature. Characteristics of photon, total 5 points are there. The first point is, the energy of each photon, that is E is equal to h nu. So already we know the formula of nu is equal to c by lambda. Then substituting, we get E is equal to h instead of nu, replacing c by lambda, c by lambda. So the first point is, energy of each photon is given by E is equal to hc by lambda. The second point is, see this relation, E is equal to h nu. So the energy of photon is depending upon the frequency. E equal to h nu. E equal to h nu. E and nu are like a dependent only. When E is increases, automatically nu is also increases. So the energy of photon is depending on the frequency. So using this relation, E equal to h nu, the energy of photon is depends on frequency. Dear students, the third characteristics of photon is, the photon travel with the velocity of light and momentum is given by, the general formula for this momentum, that is P is equal to h nu by c. So see, P is equal to h nu by c. Already we know nu is equal to c by lambda. That is lambda is equal to c by nu. So by using this equation, c just rewrite h by just a reciprocal, that is nu is come to down means like a c by nu. So instead of this c by nu, put lambda, we get p is equal to h by c by nu, that is c by nu is lambda. So p is equal to h by lambda. So the photons travel with the velocity of light and momentum is given by p is equal to h by lambda. Then fourth point is, generally this particle, that is a photon, is neutral, that is no charge. So placing this photon placing one strong electric field or magnetic field, placing that time, this is a positive, this is negative. Suppose this photon is coming means this is a neutral charge, so it is unaffected, that is not deflected, it comes to the straight line, it is going to the straight only. Because of this photon is a electrically neutral, they are unaffected by electric and magnetic field, that is not deflected both magnetic field and electric field. Then last point is, when this photon is interact with the matter, that is photon electron collision, like that time the total energy, total linear momentum and angular momentum are conserved. Okay, dear students, study well. This is a characteristics of photon. Thank you.